Hello again, advanced algebra students. So just like we use quadratics to express revenue a lot, we of course use them with projectiles, throwing objects up and watching them come down. So this is the next problem in your notes. Again, this is page 14 if you did not watch the previous video. We have two objects that are dropped from a bridge 160 feet above ground level. One object is released with an initial velocity of 0, falling only by the force of gravity. The other object is thrown straight down with a velocity of 48 feet per second. We want to write an equation for each object, where t is the time in seconds since the projectile was launched, and v is the initial velocity, ho is the initial height, and our goal here is to find out how many seconds earlier does the thrown object reach the ground when compared to the dropped object. Now, that is super important here because we are not just finding out when does each object hit the ground. We have to then apply our answers and we want to compare them. All right, so there's a lot of information that we have to pick out of these two problems. Let's get to it. I'm going to do a lot of highlighting, so if you have about 3-4 different highlighter colors, I would grab them. Now, what our equation tells us here is that t, of course, is the time in seconds. V sub 0 is your initial velocity. Y'all might be familiar with that if you with that notation if you are in physics. And h sub 0 is the initial height. All right, so before I even start to form my equations, I have these kind of stems, those equation stems down there. And I want to fit as much information from the text into those equations. It starts by telling us that two objects are dropped from a bridge 150 or 160 feet above ground level. That is your initial height. So my h sub 0 for both of these guys is 160. Now, we have one object that was dropped, falling only by the force of gravity. That means that we do not have any extra velocity acting on that dropped object. So I'm going to label the v sub 0, the initial velocity, as 0 for that one. Because the other one is thrown straight down with a velocity of 48 feet per second feet per second, my initial velocity here is, yes, 48 for the thrown object, but we are going to assign a direction to it as well. Because we are dropping downward or throwing downward, I'm going to make that a negative 48. And then we don't have to do anything with the 16t squared because that's part of our equation. So when I put all these pieces together, the equation for my dropped object looks like the height is equal to negative 16t squared plus 0t plus 160. And then the height for the thrown object is negative 16t squared plus negative 48t plus that initial height, 160. And now both of these equations I want to clean up a little bit, but also I want to know when do they reach the ground. So think about what the ground looks like as a number. If I'm talking about the height being the ground, I am asking first, when do both of these guys have a height of 0? And then I'm going to simplify my equations here. So we have negative 16t squared plus 160. We can get rid of that middle b term for the dropped object. And then for the thrown object, I'm going to go ahead and simplify this positive and negative sign so that it looks like negative 16t squared minus 48t plus 160. And now in order to solve for how many seconds earlier that object hits the ground than the other one, I have to know first, When do they both hit the ground? So I'm going to do that, check my work, and again, if you have any questions, feel free to reach out to your advanced algebra teacher. Or me, I'm Miss Jordan, if you're not one of my students. For this one, I noticed that I no longer have a b term, so I'm going to solve by taking square roots. So our dropped object reaches the ground in 3.16 seconds. Now, because we are dealing with applications in the real world, we are going to use decimals. You're going to see a lot more decimals coming back because math world, we like to do reduced radicals, but for applications, 3.16 makes more seconds to my brain than 2 root 5 or something like that. Now for the thrown object, I do have this middle b value, so I'll have to use one of my other methods to solve. But the first thing that I notice is that there is a 16 in front, a negative 16 in front. So I'm going to go to my calculator real quick on the side, and I'm going to see, is there a GCD between 16, 48, and 160? So feel free to pause, go check, come back, and you should find that the GCD is 16. So I'm going to divide by 16 by a negative 16 first. That way I can turn that t squared into a positive value. And even the 0 is going to get divided by 16. That way we can just cancel it all the way out. Now this quadratic is a lot simpler, and I am going to try to factor this. So I am going to think of two numbers that multiply to give me negative 10, but add to give me positive 3, and I'm going to do that over here on the side. Factors of negative 10 are negative 1 and positive 10, 1 and negative 10, negative 2 and positive 5, and 2 and negative 5. And so all of these groupings, when I add them, the only ones that give me positive 3 is this grouping. And then to solve this guy by factoring, I'm going to set each of those factors equal to 0 and solve for t. And I know this isn't the way that y'all probably have factored, but this is just my shorter version rather than doing the area model. Now, we talked about this last semester. You cannot have negative time, all right? Because keep in mind, these are both seconds. T is representing time in seconds. So my only option for an answer here is 2 seconds. So the thrown object reaches the ground in 2 seconds. The dropped object reaches it in 3.16 seconds. So if I'm asking again, how many seconds earlier does the thrown object reach the ground? I need to take my 2 times and find the difference between them. So the thrown object reaches the ground 1.6 seconds earlier. And that is my answer. Not 3.16, not 2, but 1.16. All right, so this is the last video. Go ahead and head over to formative.com if you have not already and do the problem that is posted for you guys for the DLD. Stay safe, stay warm, and reach out to your teachers if you have any questions. Have a good one.